Lesson 35.5, compound interest. If I were you, I would pause the video and write all of this down. There are two formulas you need to know. They're both about interest. One of them is when you use it continuously versus when you use it and it's compounded, say, monthly or quarterly or daily or yearly. That's going to be the left side, interest problems. Things you should know is that N is going to be the number of times of interest is compounded per year. So if it was monthly, it would be 12. If it was daily, it'd be 365. If it was yearly, it would be 1. Things like that we need to know. Okay, let's do some examples. Suppose $6,000 is invested at a 4.5% annual interest compounded monthly. How much would the money in the account be worth after 20 months? So things to know is that anytime we talk about time, it needs to be in terms of years. So the first thing I'm going to recommend is that you write what you know. Well, we first off know that we're dealing with A of t is equal to P times 1 plus R over N to the NT. Then we got to go P, our principal amount. We're starting with 6,000. We know R, the rate. Now they gave us a percent, but that's not what we're going to actually put in for R. We have to convert our percent. They gave us 4.5%, which equals 0.045. We need to convert that percent to a decimal. Then it tells us that we're compounding monthly. So we know that monthly, there's how many months in a year? Well, that's 12. So we're going to compound it. N is 12. And then it says how much would it be worth after 20 months? So we need to go through time. Time's going to be 20 over 12 because we're talking about 20 months over 12 months is a year. So in terms of that fraction, we're dealing with 5/3. Now we're going to plug it in to find how much A of t is. Again, you will need a calculator for this, so please grab a calculator. Plug in your formula. You have 6,000 plus the rate 0.045 over 12 times 12 times 5/3. Now from there, again, when you grab your calculator and you type all that fun jazz in, it's going to give you the answer of 6,466.397771. Now, logically, we're dealing with money, so we need to think about rounding or truncating in this case because we can't invent money that is not there. So we're going to truncate at the hundredths place, and we would have $6,466.39. We're going to do the same problem, so I'm going to copy my P, R, N, and T is just going to change. So suppose you still have $6,000, you're investing it at the same rate, still doing it compounded monthly. But now instead of time being in terms of months, they said, well, now the time is 12 years. So we know that we're talking about 12 years. We're going to use that same formula. A of t is equal to P times 1 plus R over N to the NT. I'd encourage you to write the formula every time for now so that you remember it when you take quizzes and tests later on in your future. Otherwise, you're just not going to maybe remember this stuff because you're just plugging in random stuff. Random numbers are getting plugged in. Make sure to use that formula. When you plug this then into the calculator, I get $10,285.64767. But again, remember, truncate at the hundredths place. So we're dealing with $10,285 with 64 cents. Next, suppose you have a laptop computer and you bought it for $1,200. After 5 years, it was only worth $215. They want you to find the average annual rate. Notice they give you annual in here. Annual means yearly rate of depreciation. So we know we're dealing with A of t because it didn't say continuously. The principal rate we have 1 plus R over N to the NT. Then we're going to write what we have. We have A of t. We have the depreciation value at $215. We know, and again, depreciation gives us a big hint that we should have less money at the end than we started with. We know P, the starting rate, was at 1,200 because our computer costs money and then over time it decreases in value. We know we're looking for R, but they want it as a percent. So that's something I'm going to write to remind myself, hey, don't forget when you find R, go back and convert that to a percent. And then N, well, we know N is 1 because we're talking about annual. T, we know the time. They said after 5 years, so we know we're dealing with 5 years. So now we plug in what we have. Well, we have $215 equals $1,200 times 1 plus the rate we don't know divided by 1 times 1 times 5. Now I'm going to simplify that a little bit. So we have 215 equals 1,200 times 1 plus R to the 5th power. To get the R by itself, PEMDAS matters, so I have to reverse some operations. So I'm going to reverse the multiplication first by dividing. So I'm going to start with 215 divided by 1,200 is equal to 1 plus R to the 5th power. So I'm going to grab my calculator, and I'm not going to type any of this in until the very end. This is where students start plugging in numbers, and then they round decimals, and that's not what we want because we want the actual rate. This kind of looks like a homework problem you did on 34. You have an exponent that we need to get rid of, so we're going to multiply both sides. We're going to raise it to the reciprocal rate. I'm actually going to copy what I have and then do it so that we can remember what we had at step by step. So, again, I'm going to raise both sides to the 1/5 power to get rid of that exponent. And then I'm going to have 215 divided by 1,200, 5th rooted equals 1 plus R. But again, I need to get R by itself. So to get R by itself, I would then need to subtract 1 from both sides. So I have the 5th root of 215 divided by 1,200 minus 1 equals R. And from here, this is where you grab your calculator. I'm going to do the 5th root. To do that 5th root, you're going to hit the button Math, and then you're going to scroll down to number 5, and then you can type in the 5th root, and then I'm going to put a fraction, 215 over 1,200 minus 1, and you're going to get this negative rate. It's going to be negative 0.29099. And I'm going to stop there, equals R. Now, if you think about this, we are finding the rate of depreciation. So it should be negative. We need it to be negative because it's a depreciating rate. It's going to be a value. So when I write R, R is not going to be, it's not going to be negative because remember, in the formula, technically I should have actually written this formula as a negative sign, not a plus sign, because I was depreciating. So my value makes sense because of the formula I used. Had I gone back and read that formula again very carefully with the fact that it could be a negative, I could have done that. I didn't, but I got a negative. In terms of this, we need to convert the decimal to a percent. So we multiply by 100, and you get 29. Oh, let me go back to the pen. 29.099%. If I had you truncate at the thousands, this is what the percent would look like. You were depreciating, so I'm going to put depreciate so we understand it's a negative value. Depreciating at 29.099%. Next, general question. So this kind of question, it doesn't really give me much information. It says, what annual interest rate? So again, it's telling me it's annual. Annual hints that it's not going to be continuous, but again, we're using this function A of t is equal to, again, write it down, P times 1 plus R over N to the NT would quadruple your investment in 13 years. Okay, so things that we know. We know that our A of T is going to be 4 times the principal rate because it said quadruple your investment. Quadruple your investment means 4 times the initial investment. We know P is P. It's the initial investment. It is what you plug in. R is what I'm going to search for. That's R. Annual means that N is 1. And T, they told us the amount of years. We got 13. So now we're going to find this. We're going to solve for what annual interest rate would quadruple any investment, whatever it is, within 13 years. So I set up my function. I have 4P is equal to P times 1 plus R over 1 times 1 times 13, all raised to the 1 times 13. From here, I'm going to simplify that. So I have 4P equals P times 1 plus R to the 13th power. From there, I'm going to do kind of what I did on the last one where I get rid of the initial value by dividing both sides by it. So I'm going to rewrite what I have. Well, I'm going to divide it. So I get 4 is equal to 1 plus R to the 13th power. And then, again, I have this exponent that I need to get rid of. So I'm going to take the 13th root of both sides. Or you could also claim you are going to raise it to the power 1 over 13 on both sides, 1 over 13, and that'll get rid of that 13 because I'm multiplying the exponent by its reciprocal. So my final answer is going to be 4 to the power 1 over 13 equals 1 plus R, and I have to subtract 1 again, so R 4, 1 over 13 minus 1 equals R, and let's find out what that is. When you plug that in the calculator, you're going to get 0.11253 equals R. If we wanted the annual interest rate, you now have to convert the R to a percent, and that's going to be 11.253% is the rate that would do that. Next, what is the value after 10 years of a $7,000 investment if it earns 4.25% compounded continuously? Okay, so this hints at us. Compounded continuously means different formula. Means we have this new formula. A of T equals PE to the RT. Some people might say that as PERT. Anytime I have a continuously compounded function, I think of PERT, PE to the RT. Principal, E, the number E, R, the rate at which we're interesting of, and then time, whatever the time is. So let's start writing what we know. We need to find A of T because it says what is the value after 10 years. We know the P value is 7,000. We know R is equal to 0.0425, and we know that we're dealing with time in 10 years. With that, let's plug in what we have. We don't have A of T, but we do have 7,000. E, the number 2.71 ... We're raising that to the rate of 0.0425 times 10 years. Then you grab your calculator and evaluate. When you do this, you're going to get something like $10,707, 0.13294. Again, remember, when it comes to rounding money, we're going to keep it at the decimal of the hundredths place by truncating. So we have 10,707 and 13 cents. Folks, that's the lesson. Have a great day.